Alright class, if you're watching this, that means we're close to winter break. Today we're going to do introduction to sequences. This is the sequences in series unit. So the first thing we need to do is talk about a sequence. Basically a sequence is a list of numbers. During sequences we have a few terms that we use. We use the letter N to signify the term number. So for example, if N is 5, that means the 5th term, and I'll tell you that in a second. And then A sub N is the nth term, or the value of that term. So if I said what is the value of the 5th term, then you would tell me it's blank, and that would be A sub 5. So if I list a set of numbers, you would say that N equals 1, 2, 3, 4, 5, the number of terms. And then we would call this A sub 1, A sub 2, A sub 3, A sub 4, and A sub 5. So, I would say that, for example, the 5th term, when N is 5, A sub 5 is 9, or the value of that term is 9. Okay? So the A sub is the value of the term, N is just the term number. So so another one, if I just wrote A sub 20 equals 8, that's telling me the 20th term has a value of 8. Okay, so those are some just definitions and terms that we use, letters that we use for sequences. So let's see what we can do with this. Example 1, write the first 4 terms. So that means I want when N is 1, 2, 3, 4. If A of N equals 3N. So all you do is plug in 1, 2, 3, and 4 to generate your sequence. So if I plug in if I plug in 1 for N, I get 3 times 1, which means the first term is 3. If I plug a 2 in, I get 3 times 2, which means that the number is 6, or the second term is 6. And I just keep going with this. And on this one you should actually see a pattern, and we're going to actually talk about this kind of sequence in about 2 days. You guys should notice, so this is my sequence. The first 4 terms are 3, 6, 9, and then 12. If you notice, they go up by 3s. So one way to denote that something's going up by the same amount is to multiply N by that number. That's something you're going to keep seeing as we go through, like we do for the next one. So again, I have to do the same thing. A sub 1 is 4 times 1 minus 2, which is 2. A sub 2. Oh, by the way, because this says 4n, that means that these should be going up by 4s every time, because as I change the n, it gets multiplied by 4. So we get 8 minus 2 is 6. So sure enough, we went from 2 to 6. That equals 10. And again, if you see it, you can write it down, but it's 16 minus 2, which is 14. So the first 4 terms for me here are 2, 6, 10, and 14. Again, going up by 4s. But notice how we did not start at 4 like we started at 3 here, and that's because of this minus 2. This minus 2, like, think about, it was supposed to start at 4 and then shifted it down 2. Okay, now a recursive formula means that we need the previous answer in order to keep the sequence going. In order to do the sequence, you need to know what the previous term is, or else you cannot generate the sequence. And it's written by like this. If you see, you have to have a starting point, which is telling you the first term is 9, and then you need the general recursive formula, and this here, this means the previous term. If you see A sub N minus 1, it means if I want to know the second term, that this was the first term. So just think of that always as the previous term from the term you're working with, if you see that. So now let's write out the next 4 terms. So I want to find A sub 2. Well, A sub 2 is equal to A sub 2 minus 1, which is A sub 1, plus 4. So that's equal to A sub 1 plus 4. Well, we know A sub 1 is 9, so we get 9 plus 4 is 13. So that means A sub 2 is 13. Now if I find a sub 3, that's the previous term, which would be a sub 2, which we just found. So I'm going to just go right here. It's 13 plus 4. So I'm using the previous answer to get the next one. So now I have 17. A sub 4 is a sub 3 plus 4, which is 21. And finally, the fifth term, a sub 5, is a sub 4, which we found right here, 21 plus 4, 25. So the next four terms, it started at 9, and then we went up 13, 17, 21, and 25. And again, that makes sense if you look at the formula. It's saying every time we keep adding 4. So these all went up by 4 as we went along. Alright, let's do the next ones. Write down the nth term. This is probably the hardest thing you guys are going to do. You have to figure out how to write the nth term formula. Kind of like number example 1, where it was written as an nth term formula. So we need a sub n equals. Well, if you guys notice, this is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term. Hopefully you guys see, well, how do I get these numbers? How do I get 5 if I have n of 1? Well, you can either add 4 or multiply by 5. How do I get to 10 if I'm having an n of 2? Well, hopefully again you notice, wait, if I multiply that by 5, I get 10. And then hopefully you notice that as you keep going, you notice that every n term is multiplied by 5. Since it goes up by the same amount, this is just going to be 5 times n. Okay? Now that's when it goes up by the same amount. When it gets multiplied by the same thing every time, that's when you have to assume that n is a power. So think about this again. 1/3 to the first power is 1/3. If you notice that 1/9 is just multiplying 1/3 times 1/3. That's 2 1/3. 1/27 is 1/3 times 1/3 times 1/3. So hopefully you see that every time we're multiplying by the fraction 1/3. Well, to write that out as an nth term, we just say it's 1/3 to whatever term we're on as the power. So that when n is 1, we get 1/3. When n is 2, you get 1/9, and so on and so forth. So when you have multiplication, n is usually the power. Alright, let's look at this third one. Hopefully you guys see that it's going up. This is again 1, 2, 3, 4, 5. That every number is a multiple of 6, starting with 6. So hopefully, like example 3a, you were like, oh yeah, this is 6n. But we have a problem here. We have a negative sign at the second and fourth term. Here's a little hint, guys. Whenever you have a negative sign alternating, it doesn't matter if it's 1, 3, 5, 7 or 2, 4, 6, 8, you need to have a negative 1 term to a power. That power is either going to be n or n minus 1. So let's try n first. If I make that just n and I put a 1 in, negative 1 to the 1 makes that negative. Is my first term negative? Hopefully you guys are like, no, that is definitely not negative. Which means that we can't have it be on the odds. We have to shift it by saying n minus 1. So what happens is, if I put a 1 in here, I get 1 minus 1 is 0, and negative 1 to the 0 is 1. And then 6 times 1 is 6. So now I have a positive 6. If I do the second term, 2 minus 1 is 1. 1 to the negative 1, or negative 1 to the 1 is still negative, and then 6 times 2 is 12. That'll give me the negative 12. So that is my nth term. Okay, these can be very tricky. Alright, so summation now. I'm going to try to do this as quick as possible because I do have a limited amount of time here. You're going to see these fun sigmas. Okay, and then you're going to see a letter equal a number, and then another one, and then you're going to see like a statement. This is basically your nth term formula. This is basically a sub n, like what we were finding before. This means you start at n equals 1, This means you end at n equals 4. And this big sigma-like symbol means we need to add the terms. Alright? So that is kind of what we're dealing with here. You might want to pause the screen to try to get all that down. I gotta keep going though. So, alright, find the sum. So what this is telling me is start at 4, end when n equals 7. So I'm going to say this is equal to 4 squared minus 1. But since this is a summation, we're going to say plus. So when it's a sequence, you use commas. When it's a summation, you use plus, because you're adding these numbers together. Now we use n equals 5. The next term is 5. So 5 squared minus 1. Plus the next n in the sequence, and n always goes up by an integer. So you won't have decimals or anything. 6 squared minus 1. And then 7 squared minus 1. This piece is 15. This piece is 24. This piece is 35. And this piece is 48. So this would be the written out sequence. This was n of 4, 5, 6, and 7. And then when you are done with that, you can add them together. I'm blanking on what that is real fast. Hold on. 122 is what it is. So you get 122 for the answer. Okay. Let's do that again. This time I'm starting at this time I'm using a different letter, but it doesn't matter. I'm using J. J starts at 2 and ends at 6. So I start by putting a 2 in for J for this whole thing. And then I'm going to put a 3 in for J. And I'm going to put a 4 in for J. Then I'm going to put a 5 in. And then I'm finally going to put a 6 in. So this turns into 4 plus 3 is 7. 6 plus 3 is 9. And then you should see the pattern. These are actually going up by 2's. Again, we should have known that from our nth term. 7, 9, 11. This should be 13. And this should be 15. And then when you add all that together, I'm just going to cheat a little bit and look at my answer key. You get 55. So this turns into 55. So that's a summation. Now we're going to do the opposite. We're going to have to write out the summation notation. The hardest one is actually A, because you have to figure out where this is. So this is n of 1, 2, 3, ... We don't know what this is, but you can figure it out by looking at the pattern. Hopefully you guys see that this pattern is, it's going up by 2's. This is 1 times 2, this is 2 times 2, this is 3 times 2. So that the pattern is 2n. Well, what number then is 18? What do we have to multiply 2 times to get 18? Hopefully you realize that we end at an n of 9. So then I have everything I need. I'm going from 1 to 9 with this piece. So if I write this as a sum, I'm going to write my sigma notation. I know that's hard to write for some people. It's of the function, or of the sequence 2n. I'm starting when n equals 1, and I'm ending when it's 9. And that's it. So you have to figure out the starting n, the final n, and then the sequence that you're using. Here it's very easy. If you see a sequence where it ends with an n, that is your nth term already. That is a sub n, so you don't even have to do any work. I'm going to just write 4 to the n. And we know that this one starts when n is 1. And when does it end? Well, we don't know, so instead of putting a number up here, if you have it as an n in the final one, you just put an n on top. We're just going to go to n. So that's how that one works. I know that's very confusing for you guys. Please come in with questions. This first day is actually the hardest of the series of the unit, I think. So come in if you have questions, and I will see you guys in class.